Okay, so it's now recording. Audio is on. Okay, so I'm going to share some slides that I have here. So let me start the slideshow. There we go. Okay, so before we've looked at, just in generally what is sniffing and spoofing in network security. Then after that, we looked at TCP, some types of attacks, TCP/IP attacks. We looked at various problems there. Now, if you remember, the goal here is not to, learn how to hack or do attacks, but just to have an idea of how those work so that we can focus on defense. Okay, so now we look at one of the tools that we have available for defense in the network, in network security, right? Which is the network intrusion detection system, or the NIDS, right? Or the IDS, as it's sometimes referred to. Okay, so the focus of today's lecture will be mainly on this idea of intrusion detection systems. So the network intrusion detection system. But you already, as you saw in the exam and everything, I already asked you questions about that. Because by understanding sniffing and spoofing, just understanding what we've been doing, you kind of get a feel for, okay, I do at this point, you start to understand how an intrusion detection system will work, okay? And an intrusion detection system is nothing more than C code, Python code, or some other tool, Snort in this case, or whatever, or some Cisco product that they sell you for a lot of money. But at the end of the day, whatever it is, it's just a sniffer, right? It's just some kind of a sniffer with some logic inbuilt. So today, that's going to be the main focus. Just talking about intrusion detection systems in general. This is actually a topic that I really like. It's one of my favorite things in network security because you can really make these, really smart, right? So the goal is, I should say, the challenge or the objective of this is to try to make these as smart as possible. And that's a very big challenge because this, as you know, cybersecurity is really an area of conflict, right? So there's two teams, or there's opposing teams, and one team is trying to beat the other, so they're constantly fighting, trying to, outperform the other one. And so, that creates a sort of a, what is that called? What is that term? The arms race, right? So if you guys remember the classic example of in the Cold War, right? There was the nuclear arms race, or the space exploration arms race, or something, right? So they were always trying to beat the other one, right? So the Soviet Union against, the West, the United States. And so when you think about that, you had this, one group trying to maybe be attacker and the other one defense, and then the vice versa as well. And so what happens is sorry? So one group gets some advancement in a technology, and then the other group has to counter, and that creates an arms race. And unfortunately, right now, we are in an arms race. Maybe, there's treaties, right, for nuclear or space. There isn't really an arms race in space, I don't think. But in cyber, there is one, right? So in cybersecurity, you've seen it. I mean, we hear about it all the time, and so there is this issue, right? And when you have an arms race like this, they're all, the new attacks are coming up, are being created all the time. New defenses are needed. The problems just escalate. And so that just makes it difficult, right? It makes it difficult. So one of the nice tools that's out there is, intrusion detection systems is one of the many tools. As you know, we've talked about defense in depth, and you guys are aware of like firewalls and, everything in defense, even patching and device hardening, et cetera. All of those are tools in the system that tries to protect the network or your information, right? Somebody said on the exam that, you know, arguably data is a company's more important asset, right? And, you know, that might be true. So there is this arms race, right? There is this arms race. And so the technology just needs to become better and better. So one of the pieces of that defense is intrusion detection systems, okay? And so we'll talk about them today. You know, I'll try to, you know, mention as much as I can about them, including, as I said, you probably want to check out a company called Blue Vector. Oops. So you probably want to check out a company called Blue Vector just to see what they're doing. It's an interesting company. They used to be, let's find the company on the internet, and we can, Blue Vector. So it should be, yeah, so you can, yeah, so let me share. So if you look, this company is at the cutting edge. They used to be a portion, or they used to be an asset or whatever, a piece of Northrop Grumman, and then Northrop Grumman kind of, you know, let them become their own company. And I believe now, as you can see here, they're a Comcast company, so they've purchased or they're associated with Comcast. So they do a lot of things in network security, certainly. You can take a look at, but some of the things that they're doing are actually quite cutting edge. They have very, you know, intrusion detection systems that are very advanced. They used, so I'm trying to find here. Yeah, you can see that here. Trusted by the toughest, it says. So with nearly a decade of development, Blue Vector's AI-powered solution was born to deliver the next generation of advanced threat detection and network coverage that meets the needs of any size enterprise. Deployed and actively in use across platform, global government and commercial networks, Blue Vector is trusted to provide comprehensive threat coverage thanks to our people, our technology, and their commitment. So they have this thing called the advanced threat detection, right? And you can just, obviously their proprietary technology is, you know, like a smart IDS. You can think of it like that. So they do analytics, you know, and all kinds of things. Okay, so those of you that have Comcast, which Comcast, I think, it's not here in this area, I think so. And so, or maybe it is. And so, you know, you might actually be, your network might be monitored by Blue Vector, right? So we'll talk a little bit about all of these things today. But basically, this is sort of, I want to motivate, right? I want to motivate that what we're talking about, you know, intrusion detection systems, it's what some companies just do for a living, okay? So obviously Cisco, you know, and all those other companies do the same, but at the end of the day, these are just sniffers running on a Linux type of server, and they have some very, you know, they have signatures, or they have some kind of techniques, let's just say techniques, and they understand the network really well. One of the key things that I will say about companies like Blue Vector is that they go, so as you guys know, one big issue in security is data, right? And, you know, if there's a breach in a company, let's say you're a bank or something like that, no one is going to share that data. So Blue Vector, what they have to do is they have to go into the company. They get access to the data, but they're kind of limited, you know, by laws and everything, contracts, that they cannot breach, you know, releasing that data. So they'll go in, explore threats, explore, you know, I don't know, whatever, because nobody wants to tell you what has happened. And so they'll explore that, and based on that, they're going to build, with their analytics, they'll try to build intrusion detection systems that are basically focused on that company. So one interesting thing about their approach is that, you know, maybe you think, if we think about like Snort, right? So Snort builds one set of solutions for everyone. Every company gets the same. But these companies nowadays, they can't do that, right? Because no bank wants to share their details and have it be used somewhere else for privacy or for whatever. And so what they have to do, the companies now, is they literally have to go in, kind of figure out ways of tailoring their solutions for every company. And why do I say this? Well, I say this because that's important, right? That's important because that requires you to get into the code, if you will, right? So if you just build one solution, okay, you know, I can just have one tool and it works for everyone, I really don't have to worry so much about it. But when you have approaches like that, where you have to go to every company, you literally have to be able to do what? Sniff the traffic, look at the traffic, build the rules yourself, right? So you have to build all these rules yourself that are specific for every single one of those companies. So it's very people intensive, it's very, you know, consulting intensive. But anyway, so having access to the code itself is important, and you guys have been exposed to that with, you know, libpcap and you know, Python and everything. All right, so now that I've, you know, kind of motivated that idea, right? That, you know, that idea with Blue Vector's detection system, threat detection, we can basically talk about our own, right? So we're going to talk about network intrusion detection systems, and we're going to go from not so, let's say like low IQ, if you will, to higher IQ, right? So, and what that means is from smart to not so smart, right? So we're going to start at the simplest things, and we're going to look at some advantages, disadvantages, etc. We're also going to talk about major areas of concern, like where do you place the device? So I talked a little bit about that, how they have to be specific to the geography. However, a lot of these tools can interact with the server, obviously via some kind of an encrypted, you know, imagine Blue Vector is a company, and then the, you know, the Bank of America is their client. So obviously what's going to happen is Bank of America will purchase an appliance, right? An appliance from Blue Vector. Believe it or not, these are, you know, these cost like 200,000, right? You know, something like that. You have to get a license, obviously. So a license, and then the license, what the license allows you is that Blue Vector can then download updates, you know, updates, improvements, you know, things like that, right? So so it provides some services in a sense. And then the device is going to be deployed, you know, device placement. You have to figure out where in the network you're going to have it, right? The types of solutions that you're trying to build. And then, you know, you're monitoring things from Blue Vector itself. But all of this, if it's going through the internet, of course, has to happen through cryptography, right? So, because you have to protect that information. Other things are tuning, and this I've talked about that. Actually, this is, you know, this could be called tuning in a sense, in that I'm sure a company like Blue Vector has a general appliance, right? So it's got a default settings, general settings appliance. But if they go to Bank of America, or they go to some healthcare chain, or they go to a supermarket, you know, Winn-Dixie, or they go to Strack Van Til, whomever, some company, some supermarket, they have to tune to that local environment, right? So there's a lot of things there that also you have to manage the information, right? So because remember that, whereas firewalls are kind of there to prevent things, and we'll talk about firewalls after this topic, you know, they're a little bit different. Here with intrusion detection systems, they're supposed to be a little bit smarter, right? But that just means that in essence, you want it to generate as much data as possible, but then how do you manage this data? So that's another big component there. At the end of the day, it's all network data, right? Or it's going to be log files, or it's going to be malware, right? It's going to be malware or anything else that's going on, you know, some kind of an attack of some kind. All right, so those are the things that they have to worry about. So it's not just necessarily just packets, right? But it could be higher levels. You have to look at the higher level of the packet, you know, and see what the information is at the application layer, et cetera. Maybe it's an email attachment, all of that, right? Reconstructing the email from the packets. So they look at the entire stack basically as data is being sent over the internet. So we want to think of these intrusion detection systems. And the first thing we want to probably do is we want to think about, you know, what are the techniques, right? So we understand that an intrusion detection system is nothing more than a sniffer. So whether we use SnifX or memcopy or we use the Python Scapy code, whatever it is in C or Python or any other Wireshark TCP dump, right? It's some kind of a sniffer. It captures the network data as it's, you know, being sent. We've already spent quite a bit of time just on that, so you should understand it. But then what do you do with the data, right? After you break up the packets into the different fields, you know, what do you do with it? So usually intrusion detection systems can be divided into at least two categories, which are what are called misuse detection and also anomaly detection. And I would say that a third one would be, you know, let's say smart or AI detection. Which, you know, in a sense, anomaly detection is AI detection, but this would be even further up, right? So obviously misuse is the one that we started talking about last week, right? So misuse detection is based on signatures. Okay, so you have to know the attack. So you need a model of the attack first, but at any attack that you have seen before, you analyze for a few months, 2-3 months, and then after that you can create a signature and add it to your database of signatures, very much like malware works. Okay, so you must know in advance what attacker will do. And you know, how do you know that? Well, you have to do some research, right? You need people, experts to take a look at that. And it can only detect known attacks, okay? That's one of the downsides of it, because we know that there's a lot of attacks out there that, you know, are being, you know, it's an arms race, right? So I just said that. So it's an arms race, and people are doing research right now just to kind of figure out, okay, how do I get an advantage, you know? If let's say the vaccines were a secret, right? And I don't know if it is, but you know, maybe somebody then is trying to get that recipe, right? And so obviously, you know, for companies like Pfizer, Moderna, you know, billions of dollars developing those, you know, BioNTech, and so they want to protect their intellectual property. But anyway, that's sort of the idea there, right? So misuse is known attacks. Now, a second type of attacks is something called anomaly detection. And anomaly detection is now, you know, a much more advanced approach. This might be, whereas this one is just an if statement, right? You guys have seen the example. If this is in the payload, find the attack. Anomaly is something that would use something more advanced like stats, right? So statistics. So we all know, for instance, you know, you guys took your statistics course and you know about the, oops, that looks terrible. And we all know about the normal distribution, right? So the normal distribution with a mean and a standard deviation. And then we want to know, you know, if something is close to the mean or far from the mean, you know, and therefore we can determine how similar something is or if something is an anomaly. Well, that's another idea out there, right? So can we do anomaly detection to say, well, I got this traffic pattern in the network, either a packet or a stream of packets. Does that mean that, is this an attack, first of all? Well, we don't know, but what about an anomaly? Is it an anomaly? It could be, right? And so that's another type of intrusion detection system approach or technique. So you basically use a model of normal system behavior, right? So, any model of normal system behavior, the Gaussian function or the normal distribution. And then you try to detect deviations or abnormalities from that. And if you find something like that, you're going to raise an alarm when a statistically rare event occurs. Okay, and there's obviously a framework, pretty standard, based on regular statistics. Okay, if time permits, we will look at, let's say, that algorithm, which is what you would, is what you would implement. So you would have to use something like a sniffer, and either in C or Python, and then once you've got the packets, you build this model of anomaly detection, and then you run packets through this model. The model will flag those that it thinks are the most different. You can take approaches like that. And this could potentially detect unknown attacks, right? So that's where this becomes valuable, because this only detects known attacks, whereas this one then could detect unknown attacks, or what are sometimes referred to as zero-day attacks. Okay, so zero-day attacks. So that's the idea there. Okay. So anomaly detection, as I said, it's a technique that exists for other applications too, not just for this. This could be used for other things, but certainly here you can see how it could fit in. And then, of course, a third one, I would say, there are, like what Blue Vector is doing. I'm pretty sure Blue Vector is not just doing anomaly detection. They must have other things in place. They might have some misuse. They'll use whatever they need to accomplish the job, right? So they have a task, a mission to complete, and they'll use whatever gets them to be successful in their mission, for their customers. So that's going to be misuse, anomaly, or even more advanced, AI, smart, whatever you want to call it these days, but it's just more complex also. Okay, so you have to think. So we have to look at which one is harder of all of these. So we can probably look at some ideas there. So let's take a look at the first one, misuse detection. So I already kind of talked about this one on Thursday when we were talking about Snort. So I introduced Snort, which is what we will be using for the lab. And Snort is definitely a misuse-oriented intrusion detection system. So what it is, and today I'll talk more about Snort also. So, the lab as well, if time permits. So misuse detection, or also signature-based, is when you have a set of rules defining a behavioral signature likely to be associated with an attack of a certain type. So an example is the buffer overflow, right? So if you don't know what buffer overflow, when you take 450, or you should have taken it already, you should have seen that there. So the packet payload contains special characters or strings, right? So one of the things is, I talked about this, the knob sled, right? So you have a knob sled, and that, could be something to look to flag something, right? So, but that maybe with other information. In SYN flooding attack or denial of service, a large number of SYN packets without ACKs, right? So that can be a signature. Could also, but they could also be something else. So you have to. That's why you really have to do research when you explore these things. Okay, so attack signatures are usually very specific and may miss variants of known attacks. Okay, so those are the disadvantages. So very much like with malware, right? In malware, you have the code, right? You have the code of a virus, computer virus, but then you have a polymorphic virus that changes its code a little bit, and then the hash values don't work, right? So this is sort of the same idea. Well, if they already know your packet, just modify it a little bit with a few other fields, maybe not so many NOPSLets, right? You know, or sorry, not so many no-ops in the NOPSlet. Hey, that'll change it if it's an exact match type of algorithm. And so attack signatures are usually very specific, but may miss variants of the known attack, right? They might miss it a little bit. So here, you know, when we talk about signature-based IDS, we're talking about detection of attacks by matching a set of known misuse patterns, you know, the signatures against a stream of events, right? So something that is happening in your network. So the example of this is taken directly from Snort, is that, you know, something like this, right? So this is a signature. Basically, it's looking, you know, this just says what you're, I'll explain this a little bit more later, but this explains the action to take for the IDS for a packet that is TCP, you know, that is any IP to some, that's a variable, so it means maybe a set of IPs. So in that direction to that port, okay? So those are the parameters that it looks in the packet, and also that contains something like this, right? bin.sh. You can see there's a shell, you know, similar to your TCP attacks lab where you were trying to get you know, spawn a shell, right? So this looks a little bit dangerous, right, as the payload for a packet. And so here then, this is actually known as the IMAP exploit, right? So it seems like some type of buffer overflow type of attack. Okay, so, but this is, you know, this is what a signature looks like in Snort, okay? So that's what a signature looks like, and it just translates exactly as, you know, grab the packet and look at the the payload of it, plus, you know, the TCP header, in this case, the IP header, and what have you. Now, with signature-based IDSs, you have some advantages and disadvantages. So the advantages would be, you know, an advantage is a low false alarm rate. So that's a good one because, you know, as you know, if you're looking at every packet that goes in the network, you know, getting a lot of false alarms would be a bad thing. You're going to end up with hundreds of thousands. And, you know, the system administrators simply will not be able to look at all of them, right? So you got to be, when you get an alarm, you would definitely want, you know, if that alarm goes off, it's because it's a real thing that you've detected. And so that's the advantage with signature-based, right? It's that, you know, those are attacks for sure. So it's got low false alarm rates, precise diagnostics, right? So, you know, everything is that specific attack, so you know how to approach it. However, this got some disadvantages. It's got insensitivity to attack variations. So I explained that, right? So it doesn't really, you know, what if you just change a little bit in the payload here, right? You know, something there, character 2, and it's, the attack still works, but now the signature is different. So, so that makes just maintaining the signatures very difficult, right? So that's why, you know, a lot of these companies charge, you know, a license, et cetera, for their signatures, because they're always in the business of improving the signatures. And so, you know, that takes a lot. It is a very labor-intensive thing, okay, very labor-intensive. It takes a smart person to analyze the attack and then craft the signature, basically. Now, anomaly-based, on the other hand, is what we were talking about. So here, you don't have a signature. You're really just trying to figure out the normal behavior of the network. However, remember, as I was saying with Blue Vector's example of Bank of America, you know, it's gotta be specific to that company. Okay, so it's gonna have to be specific to that company. So specific to the company. And that, you know, brings up issues with privacy of clients, et cetera, where the companies become a little reluctant to allow their data to be taken out, right, by the company that's doing the research. So that's one of the problematic issues. So detection of attacks basically by measuring deviation from statistical models of normality. And I think, whenever you think of anomaly detection, think of, as I said, this idea, right? So there's something else in AI and machine learning, which is called autoencoders. Autoencoders, which are a very fascinating idea, but it's very similar to this one. And I think the statistical one, normal distribution is usually easier. So you just look at all the data there and you look at the mean and, you look at the variance or standard deviation, and then you create some model based on the Gaussian function. And then whenever you get a new sample, you can ask the question, well, does that sample, is it similar to this distribution, or is it like further away from this distribution? Okay, so that's sort of the idea there. What you look at is you can look at traffic characteristics, protocol, packet, content, system call sequences, etc. So you can use anything of the packet, right? And that's why we've spent all this time on sniffing, spoofing, the attacks, so that you could see that there's all these fields, right, in the headers of your packets. Well, you as the cybersecurity person, now you have to think, okay, how do I model this normal behavior, right? And then how do I find things that deviate from it? So you have to kind of make those decisions on your own. Then we have advantages and disadvantages. So obviously, you're going to have detection. The advantages, you would potentially have detection of unknown attacks, or the so-called zero-day attacks. That, in theory, is good, right? So that's, because maybe I've never seen this attack, but it'll detect it. All right. One disadvantage, though, now you can also adjust your system to the traffic, given that the system is specific to that company, right? So the model is more in tune with that organization. It has to, in fact, be specific. However, it does have some disadvantages. And one disadvantage is that it would have a high false alarm rate, right? And you guys probably see that because, okay, so I say this one and then that one and then that one. Which one of those? They're all not so similar to the normal distribution here. So should they be flagged? Should they not be flagged? And also there's this other issue that an anomaly is not necessarily an attack, right? Sometimes you'll have strange behavior, something that had never happened in the network, more orders, or the patterns change. I'm sure for a lot of companies, the patterns change during the whole pandemic situation, right? And so you create these, this strange behavior, you modify the behavior from the norm, but an anomaly is not necessarily an attack. And so now you can end up with a lot of alarms that are false. And at some point, you're just not going to have enough system administrators to look at all of them. So then what do? Maybe the IDS is detecting a lot of things, but you just don't have time to look at it. So that's one of the disadvantages of this. Are there any questions so far, guys? Questions? No questions? All right. So basically, with anomaly detection, you define a profile, and you have to create it, define it to describe normal behavior. And then, some kind of statistical thing, right? So I'm not going to go into the statistics of this today, but it's just, you just have to remember the mean, standard deviation, and, the Gaussian equation. And usually those things are enough for you to think in terms of that. So you build it, you do some research, you analyze it, and then the IDS will start to flag deviations from the normal profile. Okay. So a probabilistic approach. You calculate a probability that this event or packet or whatever it is abnormal or an anomaly. Now, the third one that I mentioned was when you go, like Blue Vector, when they go even further than signature-based or anomaly-based, and then in there, they should say machine learning AI, and it just uses everything from that field to be more analytical, with the network traffic. But ultimately, the goal is to classify your data, detect it in some way. So use machine learning and data mining techniques. So you want to, look at, you want to build a model, basically. To build that model, the traditional approach has been maybe to log your traffic, your activities for a while, and then you're going to train an IDS to recognize between normal and abnormal patterns. Or even, you could do the following. You could create, let's say 1 week, you just run regular network traffic, and that creates the PCAP files for that. And then the next week you run, your netwalks and your SCAPI, attacks, right? So denial of service, all of the attacks that we're going to, that you have in Snort, for instance, you generate all those packets, right? So you grab all those alerts, all those signatures, spoof those packets, run them for a week. And now you end up with, I don't know, 1 million, 1 million and 1 million, or 100 million, I guess. 100 million packets or whatever. And these are classified in that week as just normal traffic. And then these are going to be attacks, right? And then based on this amount of data, now you can build some kind of machine learning or AI type of model that learns to distinguish, so that the next time around you get a packet, it'll say, well, I'm going to look at my data and I'm going to decide if it's normal or if it's an attack. Okay, so that's the general idea with this. And there are, of course, some risks to even this, because attackers are clever and they're going to say, well, they're training their network to detect my attacks. I'm going to start doing low-scale attacks with normal traffic to kind of confuse their network. So they can find ways around this as well. Okay. So now that I've talked about that, so I've gone from Snort to Blue Vector, right? So that's kind of the way that I've gone about this. So I went all the way from Snort to Blue Vector. There may be other companies. I'm just using that as an example. I'm sure Cisco is somewhere along those lines there. And all these companies, they'll either go from signature to anomaly to even more advanced techniques. And ultimately, obviously to provide security, the government, the military, they have to do that. Obviously, it's what they do. And then obviously corporations just make money. So, which is also a good incentive. All right, now that we've talked about all of that, we are ready then to just talk specifically about, let's say Snort or some intrusion detection systems here. So a popular one, there's, Bro, developed by Vern Paxson. We're not going to talk about it in this class, but you can check it out as well. Instead, just to keep it simple, in Linux, we can easily install this and, get a feel for the lab, right? So we have one lab assignment. So Snort is nothing more than a large rule sets for known vulnerabilities, okay? So, and you guys may know of other ones, but unfortunately some of these I've already kind of motivated that, they're businesses, so you have to pay for the rules. But here we have enough with Snort that we can do quite a bit. So as far as deployment, so you have to place the network intrusion detection somewhere in your network, right? So if we think of the classic design of of a network here, you can see there's the classic outside and inside, right? So outside and inside just means that this is the web, the internet, so it's the outside. So it's obviously the domain of trust for it is, you know, less trusted, right? More dangerous. Then you have your inside network. So that's going to be, this is your, you know, of course, your firewall, which we'll see next week, you know, what it is. But it's a network, you know, 2 network cards basically, and some routing. And then, of course, there's scanning of the packet, so sniffing. And then there's what are called ACLs, traditionally access control lists, which allow us to, you know, to deal with the packet. So we'll spend a lot of time on this. We'll talk about Linux-based, Cisco-based. So we'll definitely cover quite a bit of it. So that's why I don't really want to get into it right now. Just be aware that's just a firewall, but let's just think in terms of the IDS. So we have the outside, and we have the inside, where you have your company's network, right? You know, you might have finance, and then you have you know, human resources and whatever, right? Where your employees work. So that's the data center, all those things. That's the network inside. But you know, you might have a network tap, for instance. So usually in the lab, we just use the network tap, which has a mirror port. So it allows the traffic to continue while at the same time, because we're mirroring a port, we can connect some appliance. So in this case, that might be, you know, like Blue Vector's appliance or your own intrusion detection system appliance, okay? So your IDS appliance. So this semester, we have to do a project, right, at the end of the semester. So we'll think about what the project should be, but it's some kind of implementation of a defense, okay? So, you know, you guys know how to sniff, you know how to spoof, you know how to create attacks. So, you know, ultimately for network security, the goal would be for some kind of a defense. So in the past, some students have done intrusion detection system, you know, related projects. So you can think of that. Start thinking about what you want to do. You know, the idea being that you build some kind of a network diagram, you know, design, and then you secure some part of it. Okay, so that's usually what the project entails. But we'll talk about that at some other time. But you know, since we're talking about IDS, and there's a lot of tools out there, you can certainly think of that. And so now the idea is that these packets are going through the NIDS. The NIDS is just, as I said, a sniffer, but then there's got to be the running through one of the pieces, either the signatures or the anomaly portion, or the, you know, a nice project, for instance, for this semester would be an IDS with anomaly detection, right? Or machine learning, if you're so inclined. But anyway, so, you know, you run through that pipeline, right, of the sniffer, so sniff. Then, of course, you know, the detection, whatever that is. And then what do? You know, generating the alerts, so the alert management, if you will, right? So the alert management, and the alert management here, usually it just goes to an analyst. So you have some kind of an analyst, you know, a cybersecurity analyst, whatever it is, so that they can decide what to do, right? So that, you know, usually the intrusion detection system doesn't, because of the high processing that is required, right? Because it, you know, it would slow down the network if everything that passes through the IDS needed to be scanned. So there's a real problem there. And this, again, is the reason why, you know, we started with C++, right? So you have to understand that in the network, any software that you implement to look at packets that are going from A to B, and you're just kind of looking through them, you have to be really fast. Otherwise, I mean, your network would just be slowed down so much, right? You have to grab a packet, say it's okay and then let it go. I mean, that's going to be very frustrating for your users. So anyway, and very much like cryptography has, you know, performance issues as well to consider. All right, but that's the general classical, if you will. So this is the so-called classical NIDS deployment. Okay, so you can think of it, you know, in that sense, a couple of servers, or a server, and then a server that communicates with some client, basically client application. Okay. NIDS placement. So another concern is either before or after the firewall, right? So if you look, we could have put the NIDS there. So this is from the point of view of coming from the outside. So you're assuming, obviously, that attacks would initiate from the outside, although somebody could initiate an attack from the inside, like a disgruntled employee or something. But usually, in general, we're thinking of attacks from the outside. Okay. So NID placement then either before or after the firewall. If it's pre-firewall NIDS, this would be manpower intensive because it's going to generate many alarms, because really the idea is that the firewall would stop some of the attacks, right? So firewalls, in fact, do stop scans and all those kinds of things. And so, you know, this is going to just generate more alarms. A post-firewall NIDS is, you know, maybe more on the inside, right, of the network. So detected attacks have already passed through the firewall, increasing the degree of severity, right, because they were missed by the firewall. So they're already inside. So that's one of the dangers. So deals with limited number of hosts and services. You know, there's fewer things to look at. It might be easier to tune. Might have fewer alerts as well, right? So not as many alerts. So, but you know, that you have to consider those two aspects. So here in the pre-firewall NIDS, you know, you have this, again, this would be the internal network. So your employees have a firewall here, have a router. So this would be maybe like the DMZ where you have a switch. There's the internet. So obviously more alarms because this router will not have that many ACLs. This is the main choke point to your network that doesn't really allow anything from the outside in, that originated from the outside, trying to get inside. Post-firewall NIDS, this would be, you know, like I said, so here, internal network again, the internet, a router. Over here, this is the firewall, and then the NIDS is actually on the inside. Right? So we've already stated the advantages. Now, in general, a best practice of the network intrusion system is to try to deploy, right? So either through automation, so you want to automate this, or you want to have an analyst, or a combination of the two, right? So you want to have a combination of the two. And a lot of the systems nowadays that do IDS, that's one of the features that they offer, right? Is that they'll have automation tools to kind of help you deal with all the alerts, kind of create reports and rules, and prioritize what you're seeing. All right, so that is basically a little bit about, you know, placement, you know, the classic design of this. We talked about snort as well a little bit. Okay. Now, NIDS tuning implies basically focusing on the events you care about, right, and ignoring the rest. So you can think of it as like tuning a radio, right? So when we tune the radio, you know, we're moving to the radio station that we want. So that's the same thing here. Now, you guys understand, because you know that you can sniff the packets, you can break them into the headers, then you can figure out what you want to focus on, what types of attacks, what information in the packets, etc. This could take a long time, and it's also an ongoing process because it, you know, again, the intrusion detection system can be a very labor-intensive system, which requires, you know, human in the loop to kind of you know, tweak these things. And, you know, it's how it is, right? So, you know, whether you get a license from Cisco or Blue Vector or you do it on your own, somebody is doing the work, the tuning, right? Behind this, you know, either through the license, the company, or you yourself. But it takes a lot of work. Okay. Now, the problem with intrusion detection systems is that they do generate a lot of alarms. And so things to use are like having a priority, right? So, you know, figuring out having an IDS with a priority ranking system, trying to figure out how to turn off alarms that you don't care about. Because that's really ultimately an IDS that just generates 100,000 alerts in a day. You know, no one's going to have time to look at that. Okay, so you have to find other ways. And so it's usually like a ranking system. For instance, if you said, you know, we found all these probabilities, right? We found all these anomalies, 100,000 in a day. But we're also going to provide a probability of it being critical associated with that alert. Then when you do something like that, you can rank things from highest probability to lowest probability. And then at least you can start with the things that have the highest probability of being an anomaly, right? And so that's what, you know, what all of that means is the tuning is not just of what you look at, but also how you manage the number of alerts that you're going to be getting. And usually you're more likely, if you're ever dealing with an IDS, to be worried about the tuning of the alerts than, say, the tuning of how the IDS actually detects things. But you know, I can't stress enough, you guys now have the tools to be able to do all of this if you want it. And you can do it for your term project also, if you'd like. All right, and then now a little bit of response. And when you talk about this, actually gets into like, you know, what should the NIDS do? Because you can automate all of this, right? The NIDS could produce, you know, alerts, which could be either like messages in the network, you know, packets, spoof packets themselves to some UDP service, you know, or something, you know. So an IDS, just what is it going to do? And so here, you know, the most common response to determining which attacks, if any, you want to attempt to stop is something called shunning. Although everything in networking is funny because everything that you can use as a defense can be used against you as an attack, right? So it's this thing where, as I said, because it's an arms race, honestly, where everyone's just trying to beat everyone on being the best at this. You know, you come up with a defense, they come up with a workaround to that. So let's take, I'm not going to give hundreds of examples of this. I'm only going to cover one, which is this idea of shunning. So shunning, you know, when an attack is detected, let's imagine the simplest thing, a signature base, right? So it's a signature based attack, some kind of snort rule was triggered. So what do you do now? Automatically shunning, right? So when the attack is detected, the NIDS sends some information to reconfigure the router, right? So, you know, you remember we had, you know, some example. Like that, right? And let's say the NIDS is somewhere over here, and the NIDS detects that, you know, some packet went through here that triggers an alert. They know the source IP of where that packet originated, so immediately they communicate with the router or the, whatever you want to call this, the firewall maybe over here, and they just issue an order to add an ACL, an access control list, a rule to the ACLs that basically says, okay, whenever you see this packet with a source IP of this so-and-so, drop it. Now, don't worry about that. We'll learn, and then after we finish IDSs, we'll spend a lot of time on firewalls, and we'll look at all those things from various points of view. But in this example here, we just think of, you know, the basic idea. So the NIDS reconfigures the router or firewall with an ACL blocking the source address. Now, the problems are if you, first of all, if it was an anomaly detection system and it was a false positive, so you guessed it wrong, then you're actually blocking a legitimate user. You could also be blocking a spoofed IP, which is, we'll see how people can use shunning actually against you. All right, or, you know, an IDS kind of detects after the fact. So even if you block it going forward, well, you know, the damage could already be done, right? Because remember, we're talking about not intrusion prevention systems, which again, I can't stress enough, the problem with them is that you can't spend even a fraction of a second more on a packet that's going in the network, right? Because you're slowing down your entire traffic. And so that's very problematic. So, you know, you can't make the network. So this actually goes back to that idea. One of the questions I had on the exam, right, which I said, why do business priorities come first? Well, yeah, you would want an IDS to look at every packet and look at all the rules and not let it go through until you're sure. But then by doing that, you might be slowing down the network so much that, in fact, the company can't do its business anymore. And so if they can't do their business, you know, what's the point, right? And so that was actually one of the questions. So anyway, shunning here, it's kind of nice. There's a little diagram here. So we can take a look at shunning. We can follow the steps. So we have step one, the attacker, right? So the attacker, this is the way that we would like it to work. So there, again, remember the company. So this is the internet. So this is the external part of the network. This is the internal part of the network. This is just a firewall. This is just a router, right? And so the area of trust here, this is less trusted, and this is of course more trusted because it's, you know, further inside. So it, you know, that means that they pass through ACLs here and pass through ACLs there, right? So they pass through all of them. So launch the attack against public servers, right? So maybe, you know, attacking those servers, right? Which in this example, they're not inside, they're probably on the third interface, which is usually the DMC in some firewalls, right? DMC port. So then the attacker, you know, attacks, right? So, but the attack is detected, and they detected it came from 063. Obviously, if they spoof that IP, then, you know, the next attack will come from another one, right? But this implies that they're using the same IP. It's detected by, this is the IDS, by the way. So it's detected by the IDS, which communicates. The IDS then will communicate with the firewall, right? You know, by sending another packet. They have some kind of authentication protocol. And add an ACL entry denying traffic from that IP. And then in step 4, all subsequent attacks from that IP will be dropped. Those packets will be dropped by the firewall itself. So that is what is called NIDS shunning, okay? But even that, you know, as I was saying, could be exploited by an attacker and create a denial of service attack, right? So for instance, here we look at the same scenario. We launch the attack against the public servers, the same set of servers, but this time we spoof the packet. So you spoof the packet spoof the source IP, and the source IP is no longer the attacker's 0.63, but it is maybe some other good thing, right? 0.2150. The attack detects, and because it's a spoof packet, it blocks 150. Now the IDS communicates with the firewall to add a new ACL entry denying traffic source from IP 0.2150. And so that then all subsequent traffic from this server is blocked, but that could potentially affect hundreds of users, right? Because they were actually a legitimate IP. So you can see that, you know, there's always these little issues. So we always think, you know, oh yeah, just block the IP, but technically, some person could have the intention of you blocking a good IP. All right, so that's intrusion detection systems. So a little bit more about misuse and signature detection. So given that, at least for the lab assignment, certainly it's only signature based. I'm not, for the project, if you'd like, it can be other ones, more advanced approaches. We can certainly focus on that. But for this one, it is really only signature for the lab. So fixed signatures are used in most deployed IDS products, Cisco, ISS, Nord. I should have said, I'm pretty sure Blue Vector has some signatures as well. And other companies, there's a lot of companies nowadays that are doing networking work that are trying to compete with Cisco, although they used to be, the only one. All right, so like virus scanners, basically, I think, I mentioned this a lot, like McAfee and Symantec and all of those, like virus scanners, part of the value of the product is the team of people producing new signatures. Okay, so, I think I read some time ago that they have like one expert that only does SQL injection signatures. That's because they have to be really good at databases. So think about that, right? And then there's got to be other experts that only do like, buffer overflow things, because then they have to know about like C and how to use G-Hydra or whatever that software is to kind of reverse engineer the binary and, figure out the exploit. So it's basically, it's a lot of people producing these signatures for the newly observed malevolent behavior, right, or attacks, nefarious of some kind. Which, you've seen everything that has happened, in the last year, this year, been a lot of attacks, a lot of hacks and things. So it's certainly a very big problem. All right, the static signatures. The static signature mechanism has obvious problems in that a dedicated attacker can adjust his behavior to avoid matching the signatures. And that's the trick, right? So, attackers, you can pretty much assume that a very good attacker team, first thing they're going to do is they're going to try to figure out what the alerts look like in Snort and Cisco products and Blue Vector and all of them. And if they know that they're trying to do exact matches, they're just going to add randomness to all their attacks. Something that somewhat still accomplishes the attack, but randomizes it. If they have a machine learning based solution and they know that they're training with things that look like attacks and things that look like normal traffic, guess what they're going to do? When they do their attacks, let's imagine this is the attack, they're going to add a little piece in there that just looks like regular browsing on Google. Because all of this confuses the system, right? Think of it, or for anomaly or machine learning, whatever it is, all they have to do is make their attack look more like normal network traffic. So disguise it with some email stuff or with some Google stuff. And so it's a very complex problem, actually. So as I was saying, where was I? So the static signature mechanism has obvious problems, right? In that a dedicated attacker can adjust his behavior to avoid matching a signature exactly, right? So the volume of signatures can result in many false positives. So you have to tune the IDS to match the characteristics of your network. And this is very true. And this is actually how, as I, like from what I've heard, these companies like Blue Vector, et cetera, and all of them, they have to literally build solutions specific for each company. A one solution for all does not really work. It really won't work. So what might be unusual in a network on Unix systems might be normal in a network of Windows systems, or vice versa, right? So there's also, you know, what kind of work they do, you know, what kind of tools they use. Do they have, you know, people that just use Windows, Linux, Mac, you know, tablets, whatever it is. They have Internet of Things, whatever all the solutions are, you know, if they're all network connected. Remember what I said at the beginning of the semester, right? A marine biologist analyzes, you know, marine life. You know, if you're dealing with network security of some kind, well, packets, right? So that at least there's that common ground. At least it's, you know, we don't have all these different protocols for exchanging data. It's all common, you know, through the internet, right? Based on packets. So the volume of signatures can result in many false positives, can result in IDS tuned too low to miss real events, right? Or it can hide real attacks in the mass of false positives, right? So the tuning, really, this is related to the tuning, which is what I was saying. So, you know, if you're building a normal distribution of the data, your normal distribution can look like that. Could look like that, right? It could be very, very flat, right, etc. Right? So you can build many distributions of your data, and then to try to detect the things that are similar to your data or dissimilar from it. Okay. All right. So now I think we're ready in the signatures part to look at all right, so let's actually, this is not a good example of a signature. Let's actually, I thought this was about looking at the snort rules, but I think those are coming up in a second. Where are they? Oh, okay, so this is where they are. So snort is here. So we got to get to these because that's what you need for the lab. So let me just actually go through these slides. Let's see what else. Of course, you know, read through all of this. If you have any questions, let me know. A few things. Intrusion protection system or prevention system. That's another name for inline NIDS. And basically what that means is that this one will not let the packet go, right? But, you know, until it approves it. But the problem is this has to be very fast. It requires very fast signature handling. Because a slow signature handling will not only miss attacks, but it will also cause a delay for valid traffic, which means it's going to slow down your network. So certainly, I've said this many times already. So you need a very specialized hardware for that type of device. It might be a very pricey, very expensive device that your company may not be willing to, you know, have such a powerful machine for just that. So in this case, you know, the intrusion detection doesn't happen after the fact, but it could actually take steps immediately to drop the packet, for instance. Okay. All right, so let's see. IPS, you know, this is intuitive, right? So it's in between the inside and the outside, very much like a firewall. Network IDS here, just to, you know, keep in mind that you can have actually an IDS in the host, which you will, right? That the lab actually only requires you to implement on Linux. So it really, if the attacks are only directed at it, right? You know, in non-promiscuous mode, basically it's a host IDS. If it's in promiscuous mode, it means that not only is it scanning things directed at it, but it's detecting anything, right? So in promiscuous mode, it's a network IDS. That's really the distinction, to be honest, because you know, we don't think of an IDS as a router or a firewall with two network cards to pass the traffic. We want to think of it almost as an after-the-fact device. So really, the difference is really in that promiscuous mode, network IDS, non-promiscuous mode, host IDS. Obviously, the data that it looks like if it's in the network, it's not going to be able to assemble, the packets to, application layer. So you're basically looking at the data, the data that we saw in the SNFX code, right? So this should be familiar to you. You're just looking at the network data, payload, TCP headers, IP headers, etc. This, of course, the advantages, it's easy to deploy, right? You guys already know how to do that very well. It's got wide coverage, it's early detection, right? Also it's faster. But the disadvantages, it's not as precise, right? Because obviously something that gets built up at the application layer might have more insight. So that might result in high false alarm rates. And it does have high performance requirements. On the host IDS, which is, you might assume that's a device just looking at packets for itself. You could also have IDSs that, besides looking at the network data, they could also look at logs, right? So log files, so that's another thing that it could look at. You can see that there. So various things. But the idea, as I said, is just an IDS that is running on the local machine, usually only for the detection of things for itself. So it doesn't really care if there's an attack on this one, okay? Whereas the previous one has the goal that it wants to detect attacks to this one and that one. Therefore, it's a network IDS. Might have higher accuracy because it's only focused on itself and specific applications running on itself. It's got a precise context, it's Linux, Windows, that kind of thing. Disadvantages, obviously more work to deploy in every system, manage every system. It is also an extra load on the host itself, right? So now the host itself, its CPU and RAM might be pretty busy depending on the code. And again, that's why a lot of these things are written in C. C is, faster, more efficient. So certainly with these kinds of things, you do need the expertise of C, C++. All right, late detection in the sense that once it got to the host, well, that might be bad, right? It's already gotten to the computer in the log files, etc. So who knows what it has already done. Now, the architecture, I've talked about this basically, what is the architecture of a NIDS? So it's audit the streams, right? So that's the sniffer, right? So you can audit also logs, application logs, etc. But it's that, getting the data. Then after that, the event engine, and that, could be signature-based, AI, classification-based, machine learning, whatever you want to call it. Anomaly detection, we've talked about those. I'm not going to talk about anomaly detection, the algorithm for it today, but maybe next week we'll talk about it. And then maybe I'll do a little bit of this as well, show you guys how it works. And then finally, don't forget the last piece of this, which is to do the meta level, which is, okay, what do you do with the alarms? So you say you have an alarm, but what is there to do? Well, you could do correlations of alarms. Like if, you have multiple alarms, out of those 10 alarms, 3 alarms together might be more significant than just one alarm alone, right? Because there's the correlation there. So that is an additional layer in your program and in your tool that you're using. So a lot of these have their own management, even their own coding with syntax for just this part, right? Just this part. So the easiest thing that you can think of is, imagine if you put all the alerts in a SQL database, right? If you put all the alert in tables in a SQL database, then you could just use SQL. You guys are pretty good at writing SQL queries, SQL queries. So build your own queries to, out of the database, find even more relevant information. Okay? And that, I think this is pretty much just the same thing. You know, audit data, feature extraction, event classification, so, you know, and then the metadata, alarms, you know, and so on. Okay. So this is if you're trying to build like your own intrusion detection system, you know, you'd start with sniffx most likely, right? Because you want it to be fast. You could also do it in Python. It's just, you know, for a project it's fine. For a, obviously for a deployed product, that may not be fast enough. Same thing. So this, you know, you can pretty much read through that slide. We've already talked about. I think I just had it in there as a reminder. Remember that at the end of the day, all the data is coming from the packets, right? So if you're talking about TCP packets or ICMP packets, right? So the IP header, TCP or ICMP, some kind of a payload. You've certainly played around with that because you had the spoof packets. So hopefully that's clear for you. Okay, so you know that. I've already talked about this. This, you know, this graph just reminds us, remember, everything comes from the hardware, right? So sudo get that interface so you can either sniff or spoof. Then the network, we'll see the kernel, Linux kernel modules. And when we look at the firewall in particular, LKM will become, we're not gonna build an IDS. This just has to do with like inserting, to be really fast. Okay, so to be really fast in Linux, right, for the network, you know, just running an application at the application layer will not cut it. So you really have to create an application that is more integrated with the kernel of Linux. So there's a tool in Linux called the Linux kernel module. We will see that in the next lab. And what that does is it allows you to write code that is much more integrated with the kernel of your OS. So when you want to build an actual like IDS in Linux that's really fast, or a firewall or something, you would build it in such a way. So it's more efficient at the hardware level. So this will allow us to, you know, do certain things in the kernel. And then of course, a lot of what we've done so far in the semester has just been on the user space, the application sniffer, etc. But this is just, you know, slower. Whereas this one is a little bit faster. Okay. Obviously, if you build an old hardware device, that would be pretty fast, but pretty difficult to update. So general sniffer issues, do we want to see all traffic or only traffic designated for our host? So promiscuous mode or not. Remember, I gave you the command last week when we went over the solutions, and you've seen it along your in your book, your PDF, and so on. Okay, so those are some of the general issues with sniffers. Beyond packet capture, right? So how do we assemble packets belonging to the same number of packets per window? So this already came up. I saw some of your answers on the exam, for instance, right? So how do you, so one of the questions was, how would you detect a denial of service attack? Well, there already you were saying, well, I can't just look at one packet, right? I can't just look at one packet. I have to look at a whole bunch of packets as a collection. So I have to look at, you know, several packets as a collection. So how do you do that? Well, maybe one thing you can do is you set, instead of the unit or the sample being a packet, you set the unit or the sample to be a number of packets per window of time. So let's say in, you know, 1/10 of a second, right? So 1/10 of a second becomes your interval, and then you collect all the packets that you see in that 1/10 of a second, and then the next 1/10 of a second. But again, you gotta write this, you know, this implementation, right? So you have to. So some devices like you know, Cisco devices, firewalls actually have this built in. Okay, but you know, at the end of the day, it's just some algorithm in software. All right, so the last thing here, we still have some time, but one of the things is another library that you guys should be familiar with is libNIDS. Okay, libNIDS is a network IDS library. Okay, I'm not really gonna go, we're not gonna do a lab on this one, but I just want you to be a little bit familiar with it. All right, so you can see it's a C, C++, another one. We saw libpcap, obviously. It's actually built on top of libpcap. So the main features, it provides packet capture and replay via libpcap. So pretty much the sniffx code again, right? It makes an appearance once again. But this one can do a little bit more, like it's got functions for packet defragmentations, TCP stream reassembly. So now if you've had a TCP, right? We already talked about how do we identify a session in TCP? Well, we said, the IPs, the port numbers, sequence numbers, all of that, right? So this one, these functions allow you to, let's say there was a TCP connection. I want to reassemble that stream and look at all the packets in that stream with the element of sequence, as my input to my data. But, that is on top, it's libNIDS, or lib for network intrusion detection, as you can see. So it's yet another one for that. Right, and so here is the basic usage example of it, some main, right, and then you basically register some kind of function. Very similar to everything else we've done. But here, as you can see, the input is no longer just one packet, but it is actually a stream of packets. Okay, so it provides that additional power. That also could be a term project thing that you might want to do, right? So you just want to say, I want to, again, remember the project is you have some network and you're trying to defend it from some attacks. So this is certainly a nice topic as well for the term project. At this point, we are, in the main ideas of IDS and firewalls and VPNs and cryptography is, some of the other things. There's a few other things we need to talk about, but you can consider this as well if you're interested in that. All right, so I usually like to point out this library. Some advantages: the only known library for writing network intrusion detection system applications. It's robust. You already know pretty much some of the intuition because you looked at sniffx. Some disadvantages: moderate performance. So it's, obviously, remember, in network security, crypto and IDSs need to be fast, and firewalls too, right? So firewalls. But firewalls have the advantage that in a firewall, you grab a packet, you get the headers, and boom, you run it through some chain of rules, as we will see later on, and either matches or it doesn't match it. It's almost like in a firewall, the packet is going to go through a pipe anyway, right? So as it's going through that pipe, it's things are touching it in a way. And if something hits, it just gets dropped. But if nothing hits, it just goes through. So it's meant to be pretty fast, because again, you can't slow down the network because business priority should come first, although security is extremely important too. So it does have some moderate performance, maybe not so great. You might have some poor access, some of the headers. Poor documentation. Unfortunately, a lot of these things don't always have the greatest documentation. So certainly before you commit to do a project like this one, make sure you can find some good documentation. Although I've used libNIDS before and I know it works. Alternatives obviously would be to hack something like Snort or Bro. That's also an alternative if you want to learn more about them. But it's entirely up to you. Like I said, these are just ideas that from now on in the semester, I'm going to start throwing some ideas. And then soon we will, when we get to week 8, I think that's next week actually, we'll start talking about the term project. All right, the IDS sensor, the main difficulty in writing network sensors is the need to mimic complex protocols. We understand packet level capture. You know, I usually just use these examples because it's well understood. And we have libpcap, which is really great. When we're dealing with connection and flow level capture, it's much more difficult without a doubt. And there aren't, in fact, there's no established universal solutions for it. Right, as I said, you guys, you know, really like cybersecurity, and you know there's basically an arms race, and you basically know it's pretty tough out there. So these are the problems you will be, you know, hopefully you will be solving. All right, so that is sort of the IDS, the generic IDS lecture. Now, the next part of it is to focus on snort. So this is more now for the lab, okay? So this is more for the lab. Additionally, I guess I should say, before we get into these slides, let's talk about the lab actually, because that way you can, for those of you that may already be finished with the TCP/IP attacks, I've seen that you know, a good number of you have already submitted those labs. So let me actually then point out the lab itself, which I already posted, I think, on. So let me share. So let's go back to the, so this was the blue vector page. Let's go back to here, and let's go here. Content. All right, so we are at this point in the semester, we are here, IDS. And I think we're covering these slides here. So this must be the lab then. This is the lab. So if I click on it, no, that's this slide actually. So then it's the other one. Hold on. So maybe it's this one. Yeah, Snort Lab. Actually, that's probably. Okay, so I'm going to download that one. All right, here it is. This is your lab for this week. Okay, so all right, this is the lab for the, or for, you know, the next lab. Let's just say, what, you know, you have 2 TCP/IP labs that are becoming due in the next 2 weeks, and then you have the intrusion detection Snort Lab. So as you can see here, the lab is like this. So imagine that you have a, you know, a network, right? So kind of like we were doing today. So we have, this would be the external network. So this is, I wonder if I can change color of my pen. So this is, oh yeah, there we go. So this is the web, right? That's the external. That's the external. And this is the internal network. If you look, you have switch 1 here, switch 1, switch 2, and switch 3. This is a firewall, and this is a router, just a regular router. you would have different subnets, right? So there's a subnet here. So this might be like the 192.168.1.0. This could be the 10.10.10.0. And then this could be the 10.1.1.0, something like that. So you have these three subnets there, but that's, that's not so important. So the idea is that you want to think in terms of this, right? And then you want to have, you would usually in a network have like a network tap. And then here you have the device that has snort. Because it's an IDS, you want to put this on promiscuous mode so that it will actually capture every packet, not just the ones directed at it. Okay? This can be mimicked in the NAT network in VMware, because VMware acts very much like a hub. So you'll see everything. All right, so now you have that idea, right? And so you're going to send, you have some attacker like this one, right? Let's say on switch 1, and the attacker is going to send attacks, spoof packets of all kinds. You can try your already, the TCP IP attacks that et cetera, and you can send them anywhere, right? So you don't have to target the IDS. So in theory, you should actually target somewhere else. That's why the direction of this packet is, this is a spoof packet, an attack of some kind, but it's going somewhere else. But the IDS should actually then pick up the attacks, okay? So that's really the idea. So, okay. So, that's the setup. Like if we built a physical network, that's what it could look like. Obviously you'll build this on the NAT network in your VMware. So the goal is then you're going to craft some with Scapy here. You can see some attacks from the attacker. You're going to send them over to somewhere, but the snort device needs to detect them, right? So basically you'll run snort here on this device, and then whenever you find an attack, you want to trigger an alert. Okay, you want to trigger an alert. So okay. Give me a second. This is like stuck or something. Hold on. Technical difficulties. Give me a second. All right, there we go. So that's the sorry, I lost the data, but this is the idea, right? And then so what you guys have to do is you have to do attacks and snort, and you're going to do. There's actually 5 problems. Okay, so 5 problems just means 5 families of attacks. Okay, so for instance, what I mean by a family is I mean denial of service attacks. So you're going to go, as I showed last week, into snort, and you're going to find TFN, TFN2K, TRIN00. Those 3 attacks, okay? You need to find those alerts. You need to find out what they look like in snort, and then you're going to trigger those alerts. So how does that work? On the Linux device, on your Linux machine, right? Linux, you install snort. I gave the information for that last week. You go into etc snort. You can look at the rules. You'll get the information of what they look like. Basically, it'll start with an alert, something like that. Okay. Once you have that information, you go into the your SCAPI program, right? So you can create a script called Python DDoS.py. And this is the code exactly as it would work, right? So I've actually, for the first problem, I've given you the code. But I do want you actually, don't just run this code, actually follow this process. Go into this DDoS.rules, find these three, right? Get the alert from it, and then try to match it to the code that has been written here, okay? The code that has been written here. So for instance, you import SCAPI, you have a function DDoS, which has the IP interface account. You build a packet. You can see it's an IP, ICMP. It's got to have a type 8. It'll have a source and destination, an ID of 678, and the load is 1234. But even though I've given you this already, please go into that file and find the corresponding alert, okay? Once you build a packet, you just send it. You can plug in the fields here and then just call DDoS. Notice that this DDoS just calls the function definition, okay? This is, of course, also I gave you this last week. It's just to start snort after you install it, okay? That's just a command in Linux. So this is, your Linux terminal. Okay, so that's the first problem. And then here, actually, since you have to do 3 attacks, TFN, TFN2K, and Trin00, well, I've given you the packet for each one of them, okay? You see that, guys? So that's the DDoS rules. Then problem number 2 is really just repeating the same exercise, but for a second family of attacks. In this case, these are going to be exploits, like what you saw in 450, right? So buffer overflow attacks. So in particular, NTalkD and MountD attacks. So these are some daemons in an operating system, and they had vulnerabilities. So you can see these look exactly like shell code, right? Or not shell code, but hexadecimal values. This is code, binary code of some kind. So these are both UDP attacks, right? But again, go into the exploit.rules file, find the alerts corresponding to these. These will work if you just run them, but I want you to do practice in getting, matching these to the alerts. All right. Problem 3 is, again, a third family of attacks, scan.rules. In this case, you're going to trigger the alerts for CyberCop and for Amanda. Again, these are the packets and how you do it, but go into scan.rules, find those alerts. They'll be there by names. Just look for CyberCop and Amanda, and then you'll find, what the rules are. Okay, so that's the first 3 problems. Basically, I've given you everything for them. However, the lab actually has 5 problems, okay? So what I want you to do is to trigger alerts for 5 families of attacks. So these will be easy, DDoS, exploits, and scans. I've already given you everything. However, for the last 2, I want to let you guys do it, okay? So you have to do it. So you find other families. It can't be DDoS attacks. It can't be exploit attacks. It can't be scans. That being said, there are really hard ones and there are easier ones. So I'm letting you explore all the rules, all the signatures in Snort, and find 2 more families, and then again, trigger the alerts for those. You have to tell me, okay, I'm going to trigger these alerts for these families, and that's it. Okay, that's the lab. So that's the lab for the intrusion detection lab. If you're already done with the TCP/IP attacks lab, then you can start working on this one. Okay. All right. So that's the time for today. I will. I haven't finished the lecture, obviously, so we'll come back to this lecture at some point. But we'll stop here for now. You already have the lab. I think you have some, something to start working on if you finish the other labs. Otherwise, on Thursday we'll have a type of an open lab. So bring your problems. We can work through them in the class as well, and I might give you a little bit more information as well on Thursday. All right. So I'll stay for a couple of minutes. I'm going to pause the recording at this time.